Okay, we're going to review for the final, and our first problems are going to be inequality word problems. So for this first one, we have a scooter traveling at 10 miles per hour faster than an electric bicycle. The scooter traveled for 3 hours and the bicycle traveled for 5.5 hours. Altogether, the scooter and bicycle traveled no more than 285 miles. Find the maximum speed of each. So we know we're going to be less than or equal to 285. So 285 is greater than or equal to whatever the sum of the scooter, so the scooter's distance, plus the bicycle's distance is. To figure out the distance, so I'm going to use d for distance, that is equal to our speed, and since we want to find the maximum speed of each, call speed x, and we have to multiply speed by time to get distance, so our distance is equal to x times t. And we're going to call x the speed. I'm going to fix that so you can read it. We call x the speed of the bicycle. Then, for our speed, fix that again. For the speed of our scooter, scooter, that is equal to x plus 10. If you read it, a scooter travels 10 miles per hour faster than the electric bicycle. And since x is the speed of the bicycle, 10 miles per hour faster is x plus 10. Now let's plug these in. So remember, scooter and bicycle here are the distances, so we need to figure out the times for each. So the time for the bicycle, so t, I'll just call it t bike, is equal to, let's read, the bicycle traveled for 5.5 hours, so 5.5, and then t scooter is equal to, let's see, the scooter traveled for 3 hours. Let's go ahead and plug them back in. So I get 285 is less than the scooters, so it's going to be 3 times, so parentheses, remember, we're multiplying the whole thing for the speed of the scooter, plus the speed of the bicycle, which is 5. Or not the speed of the bicycle, but the distance the bicycle traveled, which is 5.5 times x. Okay. Now we need to go ahead and solve. So let's simplify the scooter bit first. So I need to multiply 3 into x and 3 into 10. So I get 285 is less than or equal to 3x. Let me write that in red. 3x plus 3 times 10 is 30 plus 5.5x. Next, let's add together 3x and 5.5x. I'm going to actually use a different color. Whoops. Still getting used to this. Okay, so let's use a different color. Let's use orange. I get 5.5 plus 3. So that's going to get me 8.5x. And that's less than or equal to 285. And don't forget to add 30. Okay, let's go ahead, subtract 30 from both sides. Since 30 is being added to 8.5x, to get rid of it, I need to subtract 30 from both sides. So 30 minus 30 is 0. 8.5x stays the same. And I get 285 minus 30 is 255. Now, last step, divide both sides by 8.5. And in this case, x is going to be less than or equal to 2.5 divided by, or 255 divided by 8.5 is 30. So in this case, x is less than or equal to 30 and 30 what? Miles per hour. Do not forget your units. You do need them. And then don't forget, then the speed of the scooter, so this is the bike, so I'll write bike. For the scooter, we end up with 30 plus 10 is equal to 40 mph. We'll call it scooter. Okay, that's your answer. You need your units and both answers for full credit. For this problem, you need to show me your work. That's the majority of the points. The remainder of the points comes from labeling correctly and your units. Let's go ahead. Let's scroll down. Let's answer the next one. So I'm doing several of most of the problems with the exception of one. So let's go ahead and do this problem. So we have Jack's age is 3 years more than twice the age of his younger brother, Jimmy. If the sum of their ages at most is 18, find the greatest age that Jimmy could be. So let's start with Jack. Well, we'll label them both, actually. So we have Jack, he'll be in white, and Jimmy, who will be in red. Okay. Jack's age is 3 years more than twice the age of his younger brother, Jimmy. So if he's 3 years, or not 3 years, 3 times as old as Jimmy plus 2, right? Or times 2, sorry. Let's read it one more time just to make sure. Jack's age is 3 years more than twice the age of his younger brother, Jimmy. So Jack, we have a lot of information about his age, but Jimmy we don't have as much. So Jimmy's just going to be J. So Jimmy's age is J. Jack's age, we know Jack is 3 more years than twice Jimmy's age. So 3 more, which means we add 3, and then twice his age. So Jack is 2 times older than Jimmy plus 3 years. And the last step is this. We know that the sum of their ages is at most 18. So can't be more than, but it could be equal to. So we get 3 plus 2j plus j is equal to, nope, not equal to, they have to be at most, so they're less than or equal to 18. Okay. Now at this point, we can combine some like terms, so we have to add our j's together. This is going to get us 2j plus j is, so 2 plus 1. So remember, anytime you have a variable without a number in front of it, it's just a 1. 2 plus 1 is 3j plus 3. So I'll write that in white because we can change it. And that should be less than or equal to 18. Okay, last step. Let's solve. So I'm adding 3 to 3j. So I can go ahead and subtract 3 from both sides. Okay. 3 minus 3 is 0. 18 minus 3 is 15. is greater than or equal to 3j. Divide both sides by 3. That gets me j is less than or equal to 5. So in this case, Jimmy, so we'll go back to red. So going up, Jimmy, need to spell it right. Jimmy is going to be less than or equal to 5. Jack, on the other hand, his age is going to be, I need to plug it in, so I get 3 plus 2 times 5. Jack is at least 13 years old, or at most 13 years old, right? So those are 2. And don't forget your units, years and years. So Jack and Jimmy are 13 and 5 years old. About. Next one, we have Brenda. Brenda has $500 in her bank account. Every week she withdraws $40 for miscellaneous expenses. How many weeks can she withdraw the money if she wants to maintain a balance of at least $200? For this one, we can go to the form that we kind of worked with during our unit, which was y is, we don't really know what goes between them yet, mx plus b. Okay, let's go ahead, read it again, and we can fill in what goes between y and mx plus b. Brenda has $500 in her bank account. Every week she withdraws $40 for miscellaneous expenses. How many weeks can she withdraw the money if she wants to maintain a balance of at least $200? So for Brenda, we want to make sure that she has at least $200. So for us, y is 200. M is a rate. So we want to find out the rate at which she's withdrawing money. In this case, she's withdrawing money. So when we withdraw, we lose. So we use a negative sign. She withdraws 40 a week. Then the last thing we know is she starts with 500. B is the number she is starting with. So she has 500 to start. We can now go through and just make one more determination. What goes where that question mark is? In this case, our question mark is going to be she wants to maintain a balance of at least $200. So $200 needs to be less than or equal to what's over here. So she wants to have more than or equal to $200. This is the amount of money she has. This is the amount that she doesn't want to go under. Okay, let's go ahead, fill in the information. So $200, that's y. So I put that on this side. Then I know that I have a number that is less than or equal to, and that's 200. My next number, m, is minus 40x plus the amount that she already has, 500. Okay. We have set up. Let's go ahead and solve. So I'll subtract 500 from both sides since I'm adding it to minus 40x. So 500 minus 500, that's 0. So I'm left with minus 40x. And that's going to be less than or equal to our new number over here, negative 300. So last step. I need to solve for x. To do that, I need to divide by negative 40, sorry. So if I divide both sides by negative 40, I end up with So 40 divided by negative 40, that goes away. I have x on this side. And now I have 300 divided by 40. These both become plus signs, so I'm going to get a positive number, positive amount of weeks, and it's 300 divided by 40. That's a calculator problem. So I get 7.5. And now here's the tricky part. Remember, if you divide or multiply both sides by a negative number, you need to switch your inequality sign. So x needs to be, and we'll go over checking this in a sec, x needs to be less than or equal to 7.5. Okay. If x is less than or equal to 7.5, this should work. And we can check. So if you're not 100% sure, pick a value for x that is less than 7.5. So let's pick one. Let's say it's 1. So going back, let's say x is equal to 1. And we can come back up here, and I get 200 is less than or equal to negative 40. So wherever x was, I put in 1 plus 500. Okay. Negative 40 times 1 is negative 40 plus 500 is negative 40 plus 500 is less than or equal to 200. Let's check. So 500 minus 40 is 460. Is 460 bigger than 200? Yep. So it checks out. Okay, last one. So Tracy's collecting donations for a dance marathon. One group of sponsors will donate a total of $6 for each hour she dances. Another group of sponsors will donate $75 no matter how long she dances. What number of hours to the nearest minute should Tracy dance if she wants to raise at least $1,000? So this first one, or for this one, we're going to go ahead and do the same thing. So we need to figure out for Tracy how long, or not how long, well, yeah, how long she needs to dance for. So we're going to go ahead and work that out. So she is for sure, well, first let's write our equation. Don't get ahead of yourself, Mr. Brooks. And we don't need the equal sign because this is an inequality. So we get y is something to mx plus b. Okay, so she's got a group of sponsors who will pay her for $6 for each hour she dances. So that sounds a lot like M, right? So $6 per hour. It's a rate. M is always a rate. Then another group of sponsors will donate $75 no matter how long she dances. Well, that sounds a lot like B. It's a constant rate. She will get it no matter what. So if she dances for 0 hours, she'll get $75 no matter what. What number of hours to the nearest minute should Tracy dance if she wants to raise at least $1,000? So the $1,000 that she wants is y. So y is usually what we want or what we don't want to go under or some combination of those things. And in this case, since she wants at least $100,000, she wants at least $1,000, we know that the question mark should become this. Y should be less than or equal to the amount of money she's bringing in. So let's go ahead and fill in our equation. We get 1,000 is less than or equal to M, which is 6x, plus whatever B is, 75, So $75 and $1,000. Okay. Now we can solve. This one, pretty straightforward setup. Let's just do it. So I'm going to subtract 75 from both sides because I'm adding 75 to 6x. Whatever we are adding or subtracting from x, we do the opposite. So 75 goes away. 1,000 minus 75. That sounds like another calculator problem. So 1,000 minus 75 is 925. And then I do less than or equal to, and I'm left with a 6x on this side. Now I can go ahead and divide both sides by 6. So, and we have to remember, we want to have it to the nearest minute. So I'm going to show you how to convert this to the nearest minute. So I'm going to get 925 divided by 6. So this is going to get me 154, and I'm going to take it 167, which is less than or equal to x. Well, we want to find it to the nearest minute. So let's go ahead. This guy is in hours. So I'm going to keep the 154. So I have 154 hours. And I want to convert this to minutes. So I'm going to go 167 or 0.67 times 60. So remember, there's 60 minutes per hour, and this guy's in hours. So we get 0.167 times 60. So I get 154 hours and about 10 minutes is less than or equal to x. You would need that whole answer. And I'll go and show you these. I will post these in Google Classroom so you can go through and look at them. They're not too difficult. You will get one of them on the test. I won't tell you which one, but I'm going to go ahead and move on to problem 2.